So now we're coming down to the last bit of our configuration. So let's go over to the 2950 and let's configure this guy to be the primary for 40 and 50 and the secondary for 1 and 30. So config T, spanning tree, VLAN, root, secondary. And then we'll do spanning tree, VLAN, 40, 50, root, primary. So now we've just caused a spanning tree reconvergence. You obviously wouldn't want to do this in the middle of the day because at this point, your whole network is in a state of flux. Packets aren't going where they need to go. These spanning tree timers are counting down. Really, this is not something you do in the middle of the day. You do this after hours during a normal maintenance window. So now if we go over and look at the 2960, we do show spanning tree. We're the root for 1 and 30 as we expect. We are not the root for 40 anymore because the root priority is 24.616. Our priority is 28.712. So by virtue of that fact, one of our ports are blocking because we have a redundant link to the switch that is the root for VLAN 40. The same thing with VLAN 50 over here. We can do show span tree on this guy. We're not the root for 1. We're not the root for 30. We are the root for 40 and for 50. Poor VLAN breakout switch. If we do show spanning tree brief, we're no longer the root for anything over here. And so we've got a bunch of blocking ports because of those redundant links. So now let's verify how spanning tree works, how effectively and efficiently it's going to reroute traffic in the event of a failure. So the first thing we'll do is we'll verify that for our edge ports that spanning tree port fast is not on by default. So let's do show spanning tree. We'll look at some of the other commands that's in here. In this case, we're going to do summary. So we'll do show spanning tree summary, and that tells us a good, decent summary without all of the port information that we may not care about in every case. In this case, we are in PVST mode, per VLAN spanning tree, as opposed to MST mode, which we'll talk about a little later when we discuss rapid spanning tree. It says we are the root bridge for VLAN 1 and VLAN 30. Extended System ID is enabled, and the Extended System ID is where it adds the VLAN ID to the priority. Portfast default is disabled, Portfast BPDU guard is disabled, BPDU filter is disabled, loop guard is disabled. Really everything is disabled except for Ether channel misconfig guard. We also get a summary of all the VLANs and how many ports in each VLAN are in the blocking and listening and forwarding state, so on and so forth. So that works very well on 2960. Let's run the same command on the 2950. Just to make sure that we're going to get the results that I expect to get, to be honest. So in this case, Portfast default is disabled, so unless we specifically configure Portfast on our edge ports, it will not be enabled. So, I have two hosts on my network here. I have this server and I have a Windows XP box connected to a different switch. One's connected to the 2960, one's connected to the 2950. They're both connected on port 3 on this switch. So if I go out to a command prompt here, I do ping 10.10.10.50, which is the other box on my little subnet here. You'll see that it's got a reply back from it. So without Portfast turned on, let's see how long a port takes to come online using all the default timers. So I'm going to do this, and I'm going to do a ping-t to do a continuous ping. So I'm going to the 2950 and do config T, interface fast Ethernet 0/3, going to shut down that interface. You notice that my pings stop because that interface is physically shut down now. It's just like I've unplugged the cable, although I can't unplug the cable because my lab is actually in another room so that all the fans don't get picked up on the microphone. However, by shutting or no shutting the port, I can simulate plugging in this cable very well. So let's do this, and we'll do no shut, and let's see how long it takes this guy to start responding again. So we do no shut. And we'll sit here. There's the interface that's just come up. So let's sit here, and I'm not going to pause it just so you can see how long it takes by default with non-rapid spanning tree for a port to come online. We're running about 10 seconds so far. Now remember, my workstation is not going to send BPDUs, so it's going to wait the entire 20 seconds before this port figures out, okay, I'm not connected to a switch, so let me start forwarding packets. And there we go. You saw it took about 20 seconds from the time I brought the interface up to the time that I started getting packets back from that host. Now, of course, this host is configured with a static IP address, but you can imagine if the network card came up and Windows immediately started asking for a DHCP address, it's not going to get one before Windows times out and stops looking for one. So let's stop that ping for now. And we're going to pause here, and we're going to do some more STP verification in the next video.